Okay, so hello everyone, and thank you for joining us. Today is our joint webinar on the future of process monitoring. So why are we here today? We're not going to offer you some kind of magic wand for using in process monitoring, but rather how nebumind and Authentise are working to mainstream the use of in-process monitoring tools to scale with your needs. So our presenters. Firstly, we've got Nick Parry. He heads up projects here at Authentise. And then we have Christoph, who is a developer at nebumind. And then we might have a special guest appearance from Andre, our CEO, later on. Okay, so just before we get started, I'm going to go through the webinar toolbar. You should all be able to see that toolbar there. You're all muted, so you should be able to see the little raise your hand icon. Could you just do that now so I know you can hear me? I haven't seen any hands up yet, so I hope you can. Anyone able to raise their hand? Okay, I've got one hand up. Surely someone else. There we go. Okay, there's a few more, so you can hear me loud and clear. Great. Okay, questions definitely encouraged. We're going to do a couple of polls during the webinar and also a Q&A at the end. Us presenters will switch on our webcams then as well, so it's all a bit more personal. There's a couple of handouts included in the webinar toolbar, so you can download those if you like. We'll also record it, so you can watch it again if you have to shoot off. And our contact details will be there at the end, so you can get in touch via those as well. Okay, so I think we're ready to get going. Nick's going to be kicking off, so over to you, Nick.
Thanks, Charlie. Good morning, good afternoon, everyone, depending on where you are in the world. So I'm Nick Parry, Head of Projects at Authentise. So the future of in-process monitoring. Well, the potential of in-situ sensing and monitoring methods to detect process instability conditions and those onsets of anomalies is the perfect response to dealing with the black box that is additive manufacturing. But additional sources of defects due to the incoming material quality or post-processing, such as thermal treatment, machining, finishing, etc., all contribute to the never-ending list of potential reasons for a non-conforming part. Today, in spite of additive manufacturers developing the mapping process between controllable process parameters and final quality requirements that enable repeatable builds, it's what happens internally within the geometry in its as-built state that is the major contributor to high non-conformance rates. Identifying those anomalies come at a price, with the evidence of the anomalies only coming to life during post-process and final quality checks, and in turn driving up production costs, lost machine time, wasted material, etc. Overall, eroding your margins and hurting your confidence, and hurting confidence in your customers, which comes at an enormous cost overall. The solution, though, as we know, is not straightforward, as not all defects can be predicted due to many sources of stochastic variability, but in situ process monitoring and control can represent a promising solution to prevent and control and possibly correct many defects and flaws arising in printing. Further efforts towards standardization of data formats, methods and procedures are needed, clearly, by integrating in situ measurements into industrial process and product qualification operations, thus enabling additional control and recovery actions aimed at mitigating or avoiding defects in the final part. So, Authentise and nebumind, we've been focused on this problem as part of our work together over the last year. Both companies recognize that in-process monitoring cannot operate on its own without assistance, such as dashboarding data into smaller digestible data formats, enabling real-time actions. But at the same time, Authentise's approach to helping additive manufacturers implement a full digital thread for engineering control and procedures would benefit more if quality data could be correlated to the data held within the Authentise platform, detailing those pre-production and production process steps and executed actions that are recorded within. We know the challenges already of handling in-process data, ranging from calibration of sensors, false negatives and positives that this type of sensing can bring, and finally storage and handling of large amounts of data, and then the associated computational modeling was something that we had to think about and address. In the battle to generate so much data, the requirement to receive and synthesize by the human, the engineer at the end, has clearly been lost. So to address this, we've created a kind of a light forward modeling approach by setting thresholds and only showing data of importance within the Authentise platform while providing a direct link to nebumind for further computational analysis. This in turn decouples the challenge of handling and streaming large data sets. And this outcome will be shown within the demonstration. But before we show the demo, we have some questions to ask you. So we're going to do a quick poll. Self-explanatory. It'd be good to get all your feedback and then we'll review at the end. So how big is the advantage of online process monitoring in additive manufacturing?
And share the results. There we go. Hi,
Wow.
88%.
Someone does think low. That's interesting. We'd like to speak to whoever that was.
Okay, we've got one more poll for now, and that is, do you have external sensor data which would be beneficial to be considered in the analysis? So we've got a few, so hopefully some questions for later.
Interesting.
Okay. Right, so we're now going to jump into the demo, where Andre is going to start off by telling you about the integration.
Right, so what I want to do today is just to go through a kind of an order process in Authentise, all the way from order entry to shipment, through the order review, scheduling, monitoring, and analytics phases, and of course, show you how and what data is being collected in that process that we then pass on to nebumind. And of course, as an order is generated either through an API or through a customer login, each customer can have their own login in Authentise. We've got a kind of order review stage where you can see the status of the order, the pricing information, generating a quote. You can chat with your colleagues or assign them with tasks. And of course, each object within that order has its own review panel. We call that a line item. We also manage assemblies. They're not displayed here, but the order object here, line item, allows you to set the engineering process steps that you might want to track to get the order or the part even released into production. And those prep workflow steps track who's responsible and how long they've taken. And of course, you're going to be reviewing the 3D geometry that's come as part of that order, and you might that's the information, one of the primary pieces of information that naturally we send to the nebumind algorithm. But in addition to that, you can come in here and use that to just review or set the orientation, or any number of other actions. So that's kind of on the review stage. What you can also do is add a workflow template. That workflow template will define the process steps involved, but also the workflow instructions. That each workflow instruction will require the operator or make it optional to feedback certain information to you. So you can ask them to feedback documents, pictures, numbers, or whatever else you require. And if it's within a, if it's a number, then of course you can test against the threshold, and we can assign certain kind of warnings or actions if that threshold isn't being met. So there's a QA element for the manual steps within the process for Authentise as well, and that process production workflow template that you can assign to a line item and then edit at the line item level also allows you to define the specimens that need to be included and the steps that need to be outsourced in case you need to communicate with your service providers. And that's also an option within Authentise. Every service provider has their own login. So when this review stage is done, then naturally what you're going to want to do is schedule. You can automatically schedule, or more likely in your case, you're going to want to manually schedule using Authentise's features. I'll gloss over that just to show you that naturally the next step after that is going to be the Gantt chart stages. So we have two Gantt charts, I will say loosely. One is a production Gantt chart, and allows you to see kind of an order, the status of your workflows on an order basis, and you can expand that to see where each object within that order is. And then you will also be able to see a normal Gantt chart, and then you can see the machines on the y-axis instead of the orders. And those machines are connected directly to the machine data. So we are receiving that machine data, and we'll use it to, for example, update the run status. And as we're doing that, we'll also update the order status. So a lot of automation happening based on machine data already, but naturally that's one of the critical elements that we send directly to nebumind for further processing. Each run will have a lot of information on. We'll know the priority level, we know the layout, and of course there's going to be manual steps involved in the process. So for that we have a traveler. It's a digital traveler. It's a QR code that travels on a kind of label that you're going to be able to print out, and that gets scanned by the app that we provide, and that's an iOS or Android app, doesn't matter. And that's the area where your operators will add kind of that feedback that we talked about earlier. They can do that at the kind of aggregated level, or if they want to drill down and answer questions uniquely for each object, and of course they can do that here too. So lots of options here. That's kind of the manual data collection. There's that same app is also being used for material genealogy tracking. So we track how that material is blended and used in different production processes. That's really valuable data, as is the machine data, as is, of course, the data that we're capturing from the manual steps in the process entered through the app. So all of this data is available through a variety of different sources, either through APIs or through this no-code interface, which is an integration with a tool by Microsoft called Power Automate, allows you to manipulate the data without knowing how to work with APIs. In this case, create a condition that says if the machine O2 value goes above this threshold, then send me a text message, or add it to a CSV table with these columns. That's just for people who like playing with the data. And of course, in addition to that, we then put all the data in a traceability report that's unique to every part, and that's where Christoph is taking over now. Over to you, Christoph.
Thank you, Andre. Authentise and nebumind together have realized that the integration of two software solutions can not only be a support for the operator, but can also save a lot of money for the company. So we analyzed the saving potential by means of quality check via online monitoring. Business cases show that running a printer can easily cost 675,000 euros per year. Assuming a reject rate of 30%, that's already over 200,000 euros in lost money. We think that we can detect 2 out of 3 poorly produced components. This already enables enormous saving in post-processing costs. If we get the possibility to intervene already during the process and stop the print, further process costs can be saved. In our calculated business case, the savings sum up to 68,000 euros per year, which corresponds to 10% of the total costs. In addition to the hard numbers, other benefits are also generated, such as fewer machines being blocked with faulty components, or deadlines being met by detecting faults in an earlier stage of the project. But how does the whole thing work? For each component, Authentise provides process data to nebumind. As soon as the data has been sent, nebumind automatically starts a quality analysis in the background. The result of this analysis is directly integrated into Authentise and can be seen here. It contains how often and at which point tolerances of the component were not met. In addition, further information, such as the value of the exceeded tolerances, can be passed on. On the left side, we see the 3D visualization of nebumind. On the right side, a list of critical points in the component. Each entry of this list is represented by a cube in the visualization. This allows an extremely fast overview of the frequency and the positions of these tolerances. The interactivity of the visualization allows us to investigate the cubes in more details in terms of position, value, and scale. Here, you can easily check if the areas of interest are more or less sitting close to the surface and if we maybe can remove them with CNC machining in the post-processing. For a deeper analysis, you can jump directly to the nebumind software at this point, where the data is already available in processed form. I don't want to show a deep dive into the data at this point, but maybe it makes sense to give a little insight into how the quality analysis of nebumind can look like. For this webinar, a very simple model was used for the analysis because of its clarity. This dataset here consists of 1.4 million sensor points. In order to be able to work with that number of values, a database was developed that allows a fast aggregation of the data point. The special thing here is that the aggregation takes place spatially. In very simplified terms, each cube presents all sensor values that fall within the dimension of that cube. The model used here now checks whether the highest value of each cube exceeds a certain limit or not. This can be visualized easily with a slider. In addition to this illustrative but relative trivial analysis, far more complex and profitable models can be used. For example, a simulation can be imported which provides location-related nominal values for the component. This allows for each point in space to have its own boundary around the ideal value. In addition, located related data such as the distance of the surface can be included in the quality check. If no simulation is available, a reference model can be created from past print shops that have been found to be good. Here too, limit values can be varied greatly at different locations, which provides an enormous advantage for the processing engineer point of view. This can then look like this. Through the fields here, we can select components and their sensors. So here just the components and adding the sensors. Then we can also set the aggregation form, and we can also change the cube size. The database now returns the aggregated data, and these are visualized as a digital twin. In this case, the cubes are subtracted from each other at the corresponding points in space, and the difference is displayed. But enough about the model creation, let's rather return to the workflow. Once the quality analysis has been completed by nebumind, it is displayed in the Authentise software. From here, the information and alerts can be distributed to all responsible employees. These can access the entire traceability report from Authentise, which has now also been extended by the quality report from nebumind. Here, further plots can also be seen, such as a histogram for distributing the sensor values. Based on this data, informed decisions can be made on how to proceed with the print shop.
Okay, Christoph, over to you.
Yeah, so basically what we have done in this project is we took the quality black box during the print shop and unboxed it with integrating the nebumind software into Authentise. This allows automated quality analysis as soon as the data is available. So far, we analyzed the data after the print shop, but our next step will be for sure that we switch to an in-process monitoring, which means that we analyze data during the print already. This could be, for example, after each layer, which will of course save a lot of resources. If we detect an error in the first layer, we should warn the operator immediately. One step further, we plan to integrate a closed loop control. We work on additional interfaces with the machine supplier so that a stop of the printer can be triggered if there are critical errors. Finally, we also want to adjust printing. Detecting errors during the printing job is great, but repairing them during the printing process is even better. That's why we will develop rule-based decisions, which adjust printing parameters to react on anomalies in the data. To improve the product, we also need input and feedback from you. So we have some additional polls here, and then we go directly into the Q&A session.
How many identical parts do you produce per month? So there we go. Okay, another poll. Are there any graphs or information which would be beneficial to see directly inside RapidFab? You can select more than one on this one. And if it's other, then let us know in the questions area. Were there any other questions you wanted to ask from the polls, Chris?
No, it's fine from us.
Okay, Nick, I had one here that you wanted to ask, so I'll launch that now. Do you digitally track your prep and production workflows, enabling quick correlation and auditable history of actions for every production run? A bit of a mouthful. A simple yes or no, though. There we go. All right, so we can go into the full Q&A now. So if anyone's got any questions for Nick or Christoph, please do let me know. Don't know if you wanted to share webcams, Chris and Nick. Okay, so we have had a couple of questions in already. First one came from David right at the beginning. And he is asking, you cite up to 30% non-conformance. Can you document this or cite specific examples, or is this simply word of mouth?
Nick, do you want to answer on that question, maybe?
So as the question was 30% of non-conformances, can we validate that claim? Well, to be honest, we've been speaking to a number of AM providers, and a fair percentage of those AM providers are having issues with their non-conformance rates and are reporting up to 30%. But that can depend on the complexity of the part, local features. You know, it may not be a simple part. They also could be having issues with their material suppliers, etc. And as we know, there's lots of variability within the AM process. So it's up to 30%, but there are individuals and companies actually having those rate of conformances. There was one outlier actually who was having much higher, but they were having some particular challenges at the time. Hope that helps.
Okay. Another one from David actually. Is nebumind software for in-process inspection currently being used in production where a build can be rejected purely based on in-process inspection, i.e. before final inspection?
Well, I think that's the dream of all the engineers, to just replace the CT scans and everything. So basically, no. What we say, we are more the tools that we help you to detect the errors, and it's more working together. So you need to trust our data analysis, but you also need to bring your special knowledge into the process. So that's why we help you to detect errors. You can do root cause analysis and also online monitoring. But the decision at the end is still at your side, because you know your process probably better than we do, but we can support you with that decision.
Okay, great, thank you. Last question for you, Chris, actually. What is the difference between nebumind and an ordinary sensor monitoring, oh, can't see the end of the question, monitoring, ordinary sensor monitoring?
Okay. Well, we use not only sensors, but data from different data sources that we can combine. So for example, different sensor systems, but also pre and post-process data, as for example, material or CT scans from quality control. And we can then match these data spatially, which allows us to ask where this is happening, basically. This makes us independent from speed of the machine, frequency of the sensor systems, also the exposure strategy of the printer. So I would say we have two big advantages. One is that we use different data sources and combine them. And the other one is that we move from time-based analysis to spatial-based analysis, which allows us to see what is happening where and not just when. So I think that that's other big differences.
Okay, and Caroline is also asking, is nebumind fast enough to handle all the data online?
So basically also on me, I think. You're right. Sensor systems as OT or melt-pool monitoring create a lot of data. For parts, it can be millions or even billions of sensor points. We know that we can't provide hard real-time, but we can still do it in soft real-time. I would say like that we are fast enough to follow the process. 3D printing is not a fast process, so our goal is to analyze the data while the next layer is printed. This is still early enough to create a big benefit to the operator. Maybe some specs on the database. Reading is very fast in our database. We can fetch some million data points in some seconds. Writing is a little bit slower, but you also don't print your part in 10 seconds. So to wrap it up, I would say we are fast enough to follow the print, and this is most of the time enough to have a online monitoring.
Okay. Another one from Caroline. How does nebumind create that reference model?
So basically, here we again benefit greatly from our spatial database. Beside the fusion of different sensor systems, we can also match data from different components, which just allows us to compare these parts with statistical methods and also address repeatability. So basically, also if you have multiple parts on one build shop, we can match them together and then compare them spatially. Via an API, you can fetch these data and use it, for example, as an input of machine learning. On the one hand, you can use it with your own analysis scripts and play them back in the database, but you can also use scripts provided from nebumind. So this is basically how we do the reference model.
Great, thank you. There's one more question here. I'm not sure who it's for. Are there any complex aggregation methods other than min, max, or average on nebumind which can detect anomalies?
Yeah, basically min, max, average is what's selectable, but maybe you have seen the query down there. This is kind of SQL language. It's more powerful than just selecting. To answer quickly, yes, we support basically all the statistical values, for example, standard deviation, the sum of squares, and variance. So basically, it's open to use it as a mathematic tool, and it's not just min, max, and average.
Great. Okay, are there any more questions to come in? If you have got a question, if you wanted to just raise your hand so I know you're typing. I think that looks like that's all. Okay, well, thank you so much, everyone, for attending. As I said earlier, we've recorded the webinar, so we're going to email it out to you so you can watch it again if you need. And you can contact Nick or Christoph using those email addresses there. All right, thanks very much.